Alright, in this video we round out section 4.8 on rectilinear motion. Okay. We've already discussed in previous videos the position function. We've discussed the velocity function as the derivative of the position function. And in this video we're going to round it out by looking at what we call the acceleration. Okay, this is actually the rate of change. The acceleration is the rate of change in the velocity. So the acceleration is the derivative of the velocity, or sometimes called the second derivative of the position function. Okay, so just something to point out here. We know that if we have a position function, position is a function of time, that if we take a derivative and work down, we would go to the velocity function. Okay, if you were to take another derivative of the velocity, you would get the acceleration. Okay, but an interesting question is, how do you work your way back up the chain? How would you, for example, work your way up from the acceleration? Maybe you know some acceleration information. Okay, maybe you know the velocity of your problem. So maybe you know one of these things. How would you work your way up to the position function? Okay, so for example, let's say that you know the acceleration. So for example, like from physics, we know that the acceleration due to gravity is a constant, and that is minus g for gravity. That's negative 9.8 meters per second squared, or sometimes called negative 16 feet per second squared. So let's say that you know that the acceleration due to gravity is a constant. Okay, you could then find the velocity of that problem by working your way up and finding an antiderivative. Okay, so the velocity is the antiderivative of the acceleration. Okay, and since acceleration is a constant, the acceleration due to gravity is a constant. Okay, we would then realize that the velocity is minus gt plus a constant. Okay, so what we are finding here is that we've essentially been given the acceleration as the derivative of velocity is equal to minus g. We've been actually given a differential equation. Okay, and then you can solve that differential equation by finding an antiderivative. This will tell us that the velocity, okay, is found by negative gt plus a constant. And if we should know information about the velocity at time zero, let's say the velocity at time zero is given by the initial velocity v subscripted with 0, this will tell us that the constant c is equal to v sub 0. So your velocity at any time is negative gt plus v0, the initial velocity. So if you know the acceleration, you can work your way up to the velocity by finding an antiderivative. So now your velocity would be minus gt plus the initial velocity. And if you want to work your way back up the chain, go one more step. Okay, we could then find the position. We could now say that the velocity is known. So the derivative of the position is known as v0 minus gt. And then we can work our way up to the position function by finding another antiderivative, which is minus 1/2 gt squared plus v0t and plus another constant. And if we know the position at time 0 is given by the initial position, then our position function can be found as minus 1/2 gt squared plus v naught t plus the initial position. And this is a very important equation from physics, which is the position function of an object falling in a uniform or constant gravitational field. And the answer is found just by starting from acceleration being a constant and working our way up the chain using antiderivatives. So ends this video.